Cheers everyone, Cloudfather here. Time to clean our laser. So we have everything powered down here, and we're going to get some ear protection on. First thing we got to do is clean the honeycomb out. Make sure we are picking up all the loose dust. The first thing I do is vacuum, then I'm going to change the direction for the shop vac here so that it actually blows dust out. Going to go power up the fans here so that when we blow the dust out, it puts it through the exhaust system. So now we have almost 1600 CFM of exhaust going on, which is actually more than the shop vac. The shop vac's about 1,000. So we're first going to go through here and start blowing the filters clean on the input fans. And our goal here is to try to knock as much dust off those as we can. In a few minutes we'll go through and take the laser out and clean that, and we'll go through and clean all the rails, wipe down the top. So the goal here is just to get anything loose flying back towards the exhaust fan, which is over here on this side. So the next part is we're going to move the camera a little bit here. Grab our handy dandy wrench, and we're going to remove the cables. Just a gentle rocking motion. Same thing goes with the air hose. I generally loosen up the bottom set screw, and on this unit we replace the set screws with hex cap screws, which makes it much easier for me to grab the laser. So here's what the laser looks like, and we've been running at 35 watt mode, so there's very little garbage on the bottom of the blast shield. The blast shield's important because it's keeping all the hot gases blowing this way instead of coming back around back into the fan. In a stock laser, it doesn't have this on it. Basically, the hot gases hit the surface, they blow straight back, and they're coming straight up the sides. And there's a low pressure here because there's a 55 CFM fan in the top of the laser. And what's happening is it's just coating it with hot, liquids and so on, and vapors. It's coating the entire interior of the laser, which is why we have the filters on top and bottom. So we'll set that aside here for a second. What we're going to do next is grab our lubrication and cleaning. What I use on this, and I've tried quite a few different things, but the thing that works best is this is gun cleaner, and this is gun lubricant. And since these are stainless steel rails, this is really good stuff for cleaning up the inside of your laser. Now you got to watch out for these little guys, because what happens is they get stuck in the honeycomb, and the honeycomb basically will, you can't get a level surface if that's happening. So we're going to grab some cotton balls here. And these are just, inexpensive Walmart specials. Gonna go grab a few swabs. What I use the swab for, you'll see in just a second, but we're gonna go through, and first we're gonna put some cleaner on. And all I'm doing is just putting a drop every 3 or 4 inches, or for millimeter fans, every 100 to 200 millimeters. And then we take the cotton swab and we work it back and forth. And this is basically cleaning all of the soot and so on that comes from lasering off the rails. Now I rarely use my full length of my rails. So now we have the x-axis rails are clean, and you can see that's plenty dirty. I also wipe down the front and the sides of the focusing assembly. I wipe the lead screws. And then we take a little bit of the cleaner on the end, the Q-tip, and we go through and swab the rollers. And these rollers get very dirty. You would really be surprised. And so you roll them around back and forth with the swab there. And I always wipe the front of them off too, because there's always a little excess dust in there. And take the swab and just generally wipe the top and sides and so on clean. So here's what your swab looks like after you got the rollers clean. Now these rollers now roll, they're completely smooth. Before you could feel little bumps, and those were actually caused by debris in the rollers. So now this axis is clean. Now we're going to lubricate it. So again, gun oil. And we just put a little drop every 200 millimeters. And in particular in areas where you do your most burning, I normally use XY0 plus 200 and plus 51. So now the rails are lubricated. We put a little drop behind the wheel and also in the front of the wheel, so we lubricate the bearings. And then we run this back and forth a little bit. And you notice we started to get a little bit of loose lubricant. Now loose lubricant can become a real problem with your optics. So what we do is we take the Q-tip, or the cotton ball rather, and we remove all the loose lubricant. And this will help keep the rails cleaner, so you're not getting a lot of garbage. Now the next part is we need to lubricate the feed screw, which is right here. These are the guides. And so we're going to basically run the Z-axis all the way up to the top. And we take our Q-tip here. And this is an area that collects a lot of crap, because even with the blast shield, this area is constantly getting coated with debris from your burn. And of course, if you want these fine pitch mechanics to work correctly, this all has to be wiped down. Now another thing to note is if you're looking on the bottom, there's screws here, and there's also your eccentric adjustment, which is down here. If you get wobble back and forth, you want to fix the eccentric. Basically, you loosen the 2 set screws and you'll turn it a little bit, and you'll keep going back and forth until you get rid of all the slop. Then you tighten the 2 set screws down. So now we have this all the way to the top. We got it wiped down. Now what we're going to do is roll it down a little bit. And we're going to take a little of the gun oil and we're going to lubricate both the guides. There's one on each side. And we're going to lubricate the lead screw. So first we'll bring it all the way back up again. And you'll immediately notice it's actually turning more freely. This level of maintenance you want to do at least once a week. So now we're working the oil drop that we just put in back and forth, and the next thing we'll do is we'll go down and do a quick wipe with a cotton ball to clean the excess oil off. Now one other thing, there is a new release of the manual on the atomstack.com website that tells you to set this to 5 millimeters. And so what I'm going to do is bring this all the way up. 5 millimeters is right there. We're going to take our feeler gauge and we're going to set it for 5 millimeters. Make sure I have a 0 here. Okay, so the critical measurement is from the top of this to the bottom of this. You set that to 5 millimeters. Then where you set your laser back in, this will already be adjusted to the right level. You just take your laser, put it down till you feel the focuser switch depress, and then just tighten the screws down. And that'll generally get this close enough so you won't get errors from light burn or on the console for focusing. And that's new. That's something that we didn't have before. So just wipe off our excess here so we don't get any dust collection. So again, make sure the screws in the bottom here are tight. And again, you got to make sure you've cleaned the rollers and you've cleaned the rails and just a good general wipe down. So that's the service for the x-axis. The y-axis is basically the same thing. You grab another cotton ball here. Okay, so for the x-axis, again, we'll repeat the process. And we're getting a little, cleaner on the rollers, cleaner in the bearing area. And we're putting our, 200 millimeters parts area, and we're going to do this twice, once for each side. But on this, because of the enclosure, it's much easier to do them one side at a time. So the first thing we do is wipe this stuff in. And again, what we're looking to do is get rid of all of the coating. And it doesn't hurt to wipe down your belts either. It's not really necessary, but if you're paying attention and keeping your laser clean, everything we can do to remove any dirt really helps save the servos and all of the mechanical assemblies from excessive wear. Okay, so we're going to roll this back and forth a few times, get the cleaner in. Now we're going to go for an oiling pass. Oil our wheel here. And again, you don't need to use a lot of oil. In fact, just the smallest amount you can put on, because you're going to have to wait, take all of it off once you've got it all worked in. Now, this is a good time to check your x-axis. And one of the things I look for is, are there any binding spots? Now, it is normal to feel little bumps, because what those are is these are stepper motor driven chassis, and you'll actually feel the stepper motor changing between the next step because it's reversing the polarity, and you basically have a magnetic assembly in there, and reversing the polarity causes what feels like a little bump. That's completely normal. Okay, so now we're wiping off the excess oil. As soon as we got that done, we're going to go and lubricate or clean the rollers off. So we got another little swab here. To clean the rollers, I just hold the swab on the wheel as I'm moving it back and forth. So you can see here, you just hold it right there and run it backwards. The key is to get the roller, and you can see that's fairly dirty. The key is to make sure we keep that roller clean, because every time you get a little bit of debris in there, it actually causes a defect in your image, because it's raising your z-axis, and it's probably also skewing your x and y axis, which causes registration errors on images or lines that you're trying to do a good job in terms of quality on. So keeping your laser clean is really critical for that type of activity. So now I'm going to move around to the other side here. Let me reposition the camera here so everyone can watch hysterically while we do this. And we're going to do the same thing we just did to this side. Bring our lubricants and cleaner over. So first we'll get out the cleaner. Again, you don't need much. Again, we get the pulleys, their bearings, the cleaner on it. Again, a little of this goes a long way. Now, most of the time in a large laser bed, unless you're making furniture or something, which is one of the places where the X70 really shines, you don't get as much debris on this side, but you still need to clean it. The other thing is you need to make sure that you have smooth operation. What I'm checking for is binding, and you do it from the middle. So again, you're feeling the little speed bumps. We're now going to go and put some oil on here. Again, just a little bit. Remember to get a little bit in the bearing. Again, about every 200 millimeters. What we're after is a nice, even, thin film. So now we're going to run it through. This helps work the oil in the assembly. So now we have it worked in. Now the task is to wipe the excess oil off the rails. And the final thing we're going to do is, again, take our Q-tip and make sure that we have all the debris off the wheel. And so we just kind of put it in the groove there and run it back and forth. And that completes the cleaning and lubrication cycle of the chassis itself. Now, this particular enclosure, the rear door actually opens. So if we need to adjust belt tension, which is on this end, we just flip the door up and then we can get at the whole laser. The other thing is the laser is pinned in here with a pair of 2x4s, but it will slide forward or backwards depending on whether you take the front door off or the back door off, to allow you to flip the chassis over if you need to do eccentric adjustments, which are here, here, and across. And the eccentrics are basically right down underneath, and if I remember right, they're on the outside, and this one will be back here. Now the next thing we want to do is make sure that we don't have any encroachment or problems with the cable guides. We check our belt tension, and one of the things that I'm talking to Adam Stack about is we need to design an automatic belt tensioner. We've had them in automobiles for 100 years, and it's just a little pulley that pushes down like this. It has a spring in it that adjusts the tension dynamically, and that substantially reduces gear wear. Now, some other things to pay attention to. These set screws on the couplers, of which you have 4 of them on the y-axis, those can get loose, and this is a stainless steel axle. The problem is it doesn't have beveled on it, so it's a smooth round surface, and you're trying to put a set screw on that. So these do come loose. So if you notice it's jumping around, you're getting wavy lines, check the screws. There's 4 of them on each side, and also check the set screw on the drive pulley. There's 2 screws on that. If the drive pulley slips, then left and right get out of synchronization with each other, and you're going to get wavy lines. So you want to check these every time you clean them. So that completes the chassis cleaning. So we'll reposition things here and take a break for a second, and we're going to go back through the normal daily maintenance of cleaning the laser. Okay, so we're ready to go and clean the laser. So the laser, generally, this has been at 11 days, and you can see the hot gases. These used to be clean like this. The hot gases, particularly by the dovetail here, are definitely being pushed off, but they're definitely leaving a pretty thick coating on the screws. That's not particularly important, except for the fact that the dirtiest part of the laser, if you have a stock one and you don't have the filter materials on it like this one does, is the fact that when we start getting in here, you notice this is all clean. There's no blast marks and so on, and that's what the blast shield's doing. This is the window for the flame detector. I need to get a different colored Plex for this because the orange-red, which is all I had, is not nearly as conducive to, it desensitizes a little bit the flame sensor. So the next piece is we're going to take this screw off and this screw off, which they screw into this thick piece of plastic base plate that is actually screwed into the original screws for the skirt. So we're going to take that out. Once we've got that out, then we're going to go and clean the bottom of this. Now let's look at the blast shields. This one has been run at 70 watts. It's about 30 days old. And you can see the backflash, which I keep discussing, is definitely burning up this 6mm black acrylic Plex. And you can also tell if you look at the line, I'll take a tool here and we'll put it so you can see what I'm talking about. Normally, if you don't have a blast shield, it's coming right straight back up through the nozzle. Now what the blast shield is doing is protecting the entire underneath. Everything under here you notice is very, very clean. What's happening is because we've also put a shim in the dovetail, instead of it returning here, it's now returning here, which is 1.4 millimeters from the center. And so all of this very hot exhaust gas and the reflecting of the laser itself is no longer going up the hole. It's actually burning the side of the cone. And that's really important because that saves your output lens and it saves your diode laser from getting what's called optical feedback, which will destroy the diodes in short order. So at 70 watt output, we're typically running 50 to 80% power, and you can clearly see the backblast and the backflash on this particular piece. Now you notice this piece is the one we just took off, is actually pretty clean. This is what it looks like when we run consistently in 35 watt mode, where we're doing engraving and so forth. And this is, again, keeping all the hot gases away from the laser itself, and the sacrificial shield basically absorbs all the damage. The other thing is the hole is a little bit bigger than the output cone, and so that gets high pressure air going around the outside of the cone, and that helps keep it cooler. So that's the importance of having a blast shield. And you can see it's just very simple. Couple screws, couple spacers, and there's a base, which is again the thicker Plex. And these two screws you can take out if you really needed to do any other cleaning. But again, this laser is very clean in here. There are no burn marks, there's no scorch marks. You see burn and scorch marks on the focuser probe, and the way you test if it's working properly is you should see it move like this with just a slight finger press. The other thing we'll do in a minute is take the dovetail off, and we'll take the screws out. We'll wipe it down with gun oil cleaner, and then we'll lubricate it, and then we'll wipe the lube off. That'll be the next steps. The other thing we're going to do is we're going to remove the nozzle and the high pressure air for the assist. So there's actually a notch right here. You can take a hex K in, but I didn't have one the right size. So we use this little hand turn one, and it needs about a quarter turn. So now this is loose, and it just pulls right out. And again, I don't know if you can see the output lens, but there's not even any smoke smears on it. It's completely clean. And that's after 11 days of operations. Now, lasers that do not have the top and bottom filters or the blast shields, you're going to get about 8 hours. One of the things you can use to clean is your run-of-the-mill acetone, and it isn't really necessary to clean the nozzle. I do just because. But this was cleaned 11 days ago, and you can see how dirty things like the worst thing to do is paint on ceramics. It makes these just filthy. Now, another thing is the nozzle actually removes. So you can see me taking it apart here. And you want to be careful doing that because these are very fine screws. But see, this guy's completely clean. There's no blast inside the nozzle. You know, I do clean them, but it isn't really necessary because, again, the blast shield is doing its job. Now, the air pipe is just a loose fit, so don't be alarmed if it feels loose or as you're holding it, it moves around. That's normal. Nothing to be concerned about. So now we're going to put the nose cone back on. Okay, so we're going to set that aside. Now we're going to go ahead and clean the lens anyhow. And again, if you don't have the shields and you don't have the filters, you need to do this every day. So we just put a little bit on there and just softly rotate the Q-tip around. And you can see there's nothing on that. And I know it's real difficult to see it reflecting here, but what I'm looking for are what look like after images, and what I'm seeing is a completely clean mirror. And I always take a minute to rub the sensors, clean the sighting assembly, try to take the dust out of the focuser. The probe is the weakest point of this particular style of laser because they have very small switches on them. Okay, so we have a very clean laser there. We're going to take one more clean Q-tip and we're just going to kind of go over and make sure we've got any excess off. And the best way to do this is actually take a flashlight and look at it from the side. What you're looking for again are little dust prints. And the dust prints will look just like where the beams are for the laser. Now, this unscrews. So if you need to change a lens, you just unscrew it, you pop the old lens out, you make sure that the amber side is facing the work and the blue side faces the laser. Now, a word about lenses. I keep buying from various vendors, and the only people so far that have a correctly built lens is actually atomstack.com. They have the right coatings. And if you buy a lens and it's clear, don't use the lens because this is a diffraction grating which reflects returning 455 nanometer laser light. And that's what protects the diodes. When you burn a hole in this and you burn a hole in the other coating, now the light beams, particularly if you don't have the 7.5 degree tilt put into your dovetail, goes straight back into the lasers, straight back into the diodes, and immediately starts burning them up. So there's two things that kill a diode laser real quickly: dead fans and dirt. And so everything has to be spotlessly clean. So now I'm going to go ahead and put the nozzle back in because we have this. Actually, I'm going to wait on that. I'm going to blow this thing out real quick. Hang on just a sec. All right, we're going to go and take the top filter apart here. And after 11 days, That's still pretty clean. And again, the blast shield's deflecting stuff about 200 plus millimeters away so that the air is not recycling up through the top. We're pulling out our 3M filter material, and there's a little debris in it, but not much. Here's our final filter, which is the Filtrete stuff. And you can see that's got a fair amount of brown on it, but it caught a great deal. Now, if we look inside the laser, there's very little dust in there. That's pretty clean. So that's important. You can kind of see all around here, but the filters are designed to grab several different sized particles and grab anything that's sticky. You know, gases can go through here, but if you have sticky vapor from wood or whatever, that's the stuff that these are designed to catch. Now, all we're going to do today, I'm looking in there at the fan blades. Those are pretty clean, and that's after 11 days. So I'm not going to, normally I would take out this screw, this one, and this one, and pull the whole fan out, and then cotton swab and wipe down the fan, cleaning both sides and cleaning each blade individually and cleaning the venturi that the fan runs in. But at this point in time, this is still clean, so we're not going to do that. Looks like our connectors are pretty clean. Take a swab here and just kind of wipe them a little bit. But that's about all we need to do for that. We're going to go ahead and put the new filters in. So let's go cut ourselves out a piece of, this is the Filtrete stuff. This is just furnace or air conditioner filter material. And so I usually trim the corners a little bit. Makes it a little easier to get in there. And it allows it to sit flat, which is what the real objective is. And so what we're going to do is put this guy in. And our goal is to get this guy laying flat in here. And the other thing we want to do is make sure that we can get to our connectors, which are back here. So we've got two pieces of the blue foam. Put it in the side. And again, we just play with it a little bit, get everything to lie down flat. Okay, so that's lying down there flat. We put the top piece in. So now the top is serviced. So we have vacuumed. We basically put the vacuum cleaner in blow mode and blow from the bottom to the top first and then from the top to the bottom. And so now we're putting our nose cone back on. And we've turned it to 1/8 of a turn, and that's plenty. So now we have top and bottom cleaned. Next thing we're going to do is screw the blast shield back on. We now have remounted the blast shield. Notice the window is over the IR sensor. So now we're going to take the dovetail off and we're going to go service that. So with the dovetail, you want to be gentle. It has small screws and a really flimsy limit switch for the focus probe. If you break that, you effectively have thrown your laser away, because that's not a user serviceable part unless you are an expert in electronic assembly and have surface mount tools. Now, it's relatively easy to repair the switch if it's bad. The problem will be finding the switch. And this is one of the areas that I've talked to several manufacturers about, that they should put more standard switches in. Okay, we're going to flip this over so we can get the screws out of it. So let's take a look. So you notice the burn mark. And again, for those that don't believe that keeping your laser clean and that lasers get really hot, aren't paying attention. So we're basically just cleaning up the loose dust around here. There's a little gun oil still on this swab. You can lubricate this, and you need to make sure it moves freely. It's very lightweight, takes very little pressure. But if that sticks, your focuser is going to be wrong, and you'll frequently jam your the nose of your cone into your workpiece. You can take these 4 screws out and then just rub it down with a little bit of steel wool very gently. But it usually isn't needed if you keep cleaning. You know, eventually the surface will get score and wear marks, so a little fine sandpaper and then you'd be okay. So that's in good shape. Now, the most important thing that doesn't exist on stock lasers is this washer. This washer is sitting under the 2 top screws, and this is 0.8 millimeters tall. What it does is it tilts the laser 7.5 degrees instead of having it perpendicular, and that's what's allowing us to save our laser. That's what's basically that with the blast deflector. The beam no longer hits the cone, it hits the side of the cone. Now here is, again, the weakest part of any laser that uses this type of assembly is this switch. This should have been a micro switch, or even better, a photo-optic coupler, and mounted up here so it's away from all the heat. You know, as we look at this, the temperature down here is 10,000 to 1,000 degrees. The temperature here is maybe 50 to 60 degrees over ambient temperature, because you're getting the heat from the heat sink and then it's being diverted out the sides. These guys, without any of the protection on the bottom, get hot, as the circuit boards are right there. So again, good reason to put a blast deflector on. And this is the part that all the vendors that are using this type of switch need to get rid of and go to a standard photocoupler or a good quality micro switch. So now we're ready to put this back on. And again, care and finesse is important. Where this little button's going to hit is right there. And so what we do is we point it over here a little bit. And then we line the holes up. The other thing I want to do is make sure that this spacer is between the 2 screws. So I turn them just so that we get a few threads in. And I keep testing to see that everything is free. So I start with the bottom 2. Again, I'm just getting it so it starts to snug up, and we keep testing to make sure that is working. And then the top screws, we're going to go about 1.5 to 2 turns. And we want them just to start to snug. Just a hair. And again, this assembly, finesse is really important. And you keep checking to make sure that your focus switch is acting freely. So now just a gentle, slight tightening, and we're good to go. So now at this point, the laser is clean. We've had the primary filter up here on the top has been put together. Now we're going to go cut some filter paper up and make us a new set of outside filters. Now the outside filters, again, are just like what you use in a race car, especially if you're doing dirt racing or sprint car racing. Biggest problem we have is getting loose parts and lots of dust. So this bottom filter, again, this is standard furnace vent filter. You can get about 10 pieces for $6 at your local neighborhood Lowe's. My husky likes to go because she gets lots of dog cookies and pats from all the employees. And so for this filter, the easiest way is just take a piece of tape and put it there. Although usually I just use a rubber band. That works equally as well. The rubber band is nice because I can get it behind the dovetail. And again, we're just looking to get the filter to line up. Remember, this is an air output passage. Originally, the air came down and bounced off and actually went straight back up to the top. Now it's all both with the blast effector moving the air this way, and then the output air going in 4 different directions creates a big wall of wind. And when you put this back in the bed and you close the top, you can actually watch the smoke flowing away from the laser, which was the whole point for this. So now we made sure that we don't have the focus switch bound, and again, we keep pressing it to test it. And again, your primary goal is just to get it as close as you can. And again, tape works just as good as rubber bands. Rubber bands are just what I had sitting around. Ideally, I'd love to get some, have a stretchy or something that would fit over this you could throw in the dishwasher. Maybe one of these days I'll get around to doing that. So that's the top side. Now at this point, this is where we put it back into the bed assembly. All right, now we're going to go ahead and put the laser in the bed. Remember, we adjusted for 5 millimeters from here to here. And we slide the dovetail in like that. It's a good time to check your cables. This is your data and control cable. This is your power supply for the laser. So this is the plus 36. This is the signal that determines how much power the laser has, which is from 1/10 of a volt to 3.3 volts. Could be different on smaller lasers. In the center is the ground. Then the other thing we will put on will be the air pipe. Now the laser head has got its filters mounted. We've got both cables in, got the air tube in. Now we'll grab a couple of zip ties. And again, you could use tape. The key thing is don't use too wide a piece because you don't want to impact the airflow So we have the top piece, and this is an outer filter. And basically, same drill. We're just going to overlap it. There we go. So not super difficult, but that's what you need to do to keep your laser in shape. So the next thing we're going to do is we're going to adjust the Z-axis to make sure that the laser is at the right height. So the first thing to do is power up the laser, turn it on, make sure it's gone all the way through its startup cycle, and also make sure that you see the zeroing is successful message and you'll see it moving around. So that's the first place we want to start. Then what I do is I use light burn using the location function because the RC4 doesn't work properly. And I'm basically putting the laser so that I have it centered on a piece of scrap that's a millimeter thick. Okay, so now I'm going to press the autofocus button, and what I'm looking for in the console window and on the display is to see if it completes the cycle, because that will tell me how far down I have to move the laser in the assembly. Now I'm going to run the macro here. What I'm watching for is to see if it touches and then goes back up. Okay, so the laser is too high, so we're going to go ahead and loosen the set screws. Bottom one first is usually better. It's a little more control. The other thing I do is I like using the focus block in this too. And it's this step, not this step, because that middle step puts a laser head at 15 relative to the surface. Okay, so now we got its nose on there, on the 15. I'm just finger tightening so I can move it back and forth, make sure it's under there. Add a little tension to the screws here. I'm going to pull that out. So it's 15 millimeters from the top of this to the bottom of that. And the normal resting position when you come from home or you've done a system startup is at 15, although Z will read 0, but that's where it should be. And remember, we started by setting the knob here, so we had 5 millimeters on the bottom. Now we'll hit the focus button again and see if it touches. If it touches off, then we have it about right. Now we may still need to go a little lower. If you see it sitting like that, that means that you're going to get a homing alarm 7 saying it can't reach the bottom. But we know we have it fairly close. So we're going to ease the head a little bit and drop it just a hair. Now, our objective is to get it so it just touches that 1 mil piece. Yeah, we still need to go down a little bit. If it touches successfully, you'll see it go down twice. It'll touch. What we're waiting for is the focusing switch down here to show closure. There we go. You saw it come back up and then go back up twice. Now it's adjusted correctly. So all we have to do now, let's put about a 16th of a turn, just snug, just so you don't get me wobbling the head. So now the laser is basically ready to use. Again, this is just a piece of scrap aluminum that happens to be 1 mil thick. You could even use a piece of paper, but I like the aluminum because it's more stable dimensionally. So now the laser, the bed is all completely clean. We have lubricated everything. We've cleaned the rollers. The Z-axis is all set up. The head's all been cleaned. The filters have been reapplied. So now the laser is ready for a few days of use. And again, one of the other nice things about the filter, as you can see, when it gets dirty. And that's helpful. And again, the difference between having filters and not is over 10 days of use between cleanings. With a 70-watt laser, they generate much more debris clouds, and when you're in an enclosure, even with 1600 CFM going from one side to the other, they still get very dirty. So it's really important that if you're not using filters, you're not using a blast shield, that you take your laser apart every day and clean it. Blow the air through it, pull the nozzle off, clean the output lens, and then put it all back together, clean and lubricate your chassis. And again, if you're doing heavy work like ceramics with paint, that you're going to have to do every 4 hours. And that's the real trick to keeping lasers running a long time. Cloudfather out.